So now that we have started working with inequalities, we refreshed our memory on what the heck is an inequality, how does that work, we can start to solve them. So just as we did with equations, we are going to use our friends' inverse operations to solve these inequalities. So with inequalities that include addition or subtraction, the only change here is that there's going to be more than one solution. So it's going to work just like solving an inequality or solving equations, except we are going to find a range of values that make the inequality true. And we're also going to be able to graph our solutions because rather than being one singular value, we can see the range on a number line. All right, so let's go ahead and solve here. If x minus 18 is greater than negative 24. So if I want x to be by itself, I'm going to come up with a zero pair by adding 18 to both sides, which will cancel out this minus 18. All right, so we're going to add to cancel that minus 18. And so what I'll have now is x is greater than negative 6. And so here is my number line already numbered for you. And so I'm going to put an open circle at negative 6 because it's strictly greater than, and then we want values of x that are bigger than negative 6, which are over here to the right. And then there you have it. And remember, all of these values that are marked by that green ray make the inequality true. It's not just that one value. All right, so let's go ahead and look at x plus 4 is greater than 7. So here I have addition that will undo by subtracting 4 from both sides. And now I'm going to have x is greater than 3. And so, again, I already numbered my number line. I'm going to go here and put an open circle at 3. And draw the rest of my arrow. So you can see that's where my answers are. All right, let's go ahead and try a word problem here. So Drew has a budget $200 at the grocery store, and he knows he will need to spend $15 on the most important item, dino nuggets. All right, so this budget of $200 means he can't go over. So he can spend exactly $200 or he can spend less. And he knows he has to spend $15 on the most important item, dino nuggets. All right, so he's going to be spending $15 on dino nuggets. We want to write and solve an inequality that represents how much he can spend, S, so I've already defined the variable for you, on the rest of his groceries without going over his budget. All right. So we know that he has this budget of $200. Okay. And whatever he spends is going to have to be smaller than or equal to 200. So we're saying 200 is greater than or equal to whatever he spends, right, at the store. This is how much he spends total. Now we know his spending total, right, is given to us by this $15 that he's going to spend in Dino Nuggets plus this S, which is what he's spending on the rest of his groceries. Okay? Here, maybe I should have written this up here. So this 15 plus S, that's going to be his total. So if we're going to solve to see what he can spend the rest of his budget, we'll end up taking away that 15 for the Dino Nuggets and seeing what's left. And so we'll have 185 is greater than or equal to S. Or if it makes more sense to you, you can write it this way, making sure the direction also gets changed, right? So it means that S is still the smaller thing, okay? And so we can use this little symbol here. It means therefore. And it says, therefore, Drew can spend $185 or less on his remaining groceries. Okie dokie. Next, we're going to solve each inequality, and then we're going to graph our solution. So I want you to go ahead and try out example 3 here. So you already have all the tools in your tool belt to make this work. So go ahead, get started, and then we'll come back and go over them. All right, welcome back. So let's see what happens here. We are adding 8 to both sides. And so now what happens is that cancels. End up with x is less than -4. Okay. So now we need to box that up so that we know that's our answer and graph it. So x is less than -4 means we have an open circle here. -4, wow, that wasn't very circle-like, huh? Open circle, all right, and then we want smaller than -4, so going into the left. Over here, we're adding 15, so we need to undo that by subtracting 15, and now I've got x is greater than or equal to 3. And then we are going to look at putting a closed circle here at 3 because we are including 3 since we have that equal to symbol. And then we want anything bigger than that as well. All right, last 2. All right, so now we can add 2 to both sides. I've got x is less than or equal to 1. And feel free, right? That's the glory of these videos is you can speed up or slow down or pause or go back and really mold this to whatever level of support you need. So here we have got x is less than or equal to 1. There we go. All right, and then over here, we're going to subtract 6 from both sides. And we're going to have x is greater than or equal to -3. You know what? That's kind of confusing. I flipped that around on you. So let's try that again. Let's say that -3 is less than or equal to x. There you go. And again, if I'm graphing that, this guy's going to have a closed circle at -3 because we're including that boundary value. And here, notice it says that the x's, if you think of this as like a hungry alligator, mom, it's eating the x, right? So it says that's greater because it wants more food rather than less food. So we'll draw our arrow this way. There you go. All right, now we're going to talk about one of my favorite things, which is vacation. So you are flying to your destination for vacation, and you're going to check a bag. So if you've never flown before, what this means is your bag isn't coming onto the plane with you, it's going on the belly of the plane, and you'll get it back once you land. So, which is kind of nice because there's different requirements for how much you can fit in it. It can be bigger than what you bring on the plane with you. And you don't have to lug it through the airport, which is especially nice, like if you have connections and you have to fly somewhere else first before getting another flight to your destination. All right, so that's a little bit about flying. Anyways, your airline states that your luggage must weigh less than 50 pounds, right? Because there's restrictions about what can go on planes and what can't. And like in terms of the weight of the plane. You weigh your bag at home, and its current weight is 39 pounds. So far, doing great on packing. Let's write and solve an inequality to determine how much more you can add to your suitcase without having to pay an additional fee. So let's say let x be equal to the additional weight in pounds. All right, so we have x is how much we're currently, or how much more we can add. Well, hold on, let's start this over. All right, so we can make it to 50, right? It has to be strictly, 50 has to be, wait, hold on. Whatever we do, we want it to strictly be less than 50, all right? So 50 is going to be greater than whatever our final weight comes out to be. We are currently at this 39 pounds. We want to know how much more can we add before we get to that danger zone. All right, so we're going to go and solve. We'll take 39 away from both sides. And we'll end up with 11 is greater than x, right? So therefore, right, you can add 11 additional pounds. And I know what you may be thinking. I did not need to write an inequality to figure that out. And you're totally right. Okay, so this is for real, a real problem, right? Flying somewhere recently, had 39 pounds, and you need to think, okay, what else can I put in this suitcase? Because I don't have to, it's up at 39 pounds. But if I need a couple more things, if there were items that I didn't know if they were going to fit, right, maybe I need to add more. Okay, so to think, all right, well, if my goal is 50, I need to be less than that, right? So I have 11 pounds of wiggle room, right? So I can't add exactly 11 pounds, but so maybe I should amend that up to, right, but not including. Anywho, I just subtracted, right? I just said 50 minus 11, and in my brain, I knew that that wasn't an exact answer. I didn't need to add exactly 11 pounds to my suitcase, but I had that range that I could work with. And so why we use problems like this, if we can solve them another way, why we use problems like these to model writing and solving these inequalities is because it's easier to grasp writing these inequalities at this level so that we can practice and build up to the times where we wouldn't necessarily be able to solve it mentally and we would have to write and solve an inequality, right? So often what I see as an Algebra 2 teacher and even beyond, even when I was tutoring calculus, was students would get by on just thinking through the problem and not mastering the fundamentals at this stage in the game. And then when it got to the point where they really had to rely on inverse operations to be able to solve a more complex equation, those skills weren't there, right? They hadn't mastered that foundational piece. So, all right, I'll get off my little soapbox there. Thanks for solving some inequalities with me, and I'll see